this last presentation, we have here three different profiles. We will try to discuss what's needed for future generation of engineers. We call it the title, the knowledge and skills for future hydropower. George, going from the right, Karalis is from Athens. Then we have Daniel, who you already, no, sorry, Roberto Renato Stopar from a company, from Turbo Institute, Spada Turbo Institute from Ljubljana, and then Daniel, who is actually still a student, and we'll try to highlight opinion on students, how they feel about hydropower. So,
To educate him.
well, to educate us. I would prefer if this last session for today is kind of it's more discussion, because you will see that discussion for this topic is, I guess, more appropriate than the lecture. And my name is Marco Hocheva. I'm from University of Ljubljana. Page down. Before we jump on that, so to start with Roberto Stopar and his presentation, I would like to just say a few words on the European Union, but you may have noticed that already. For instance, there is in European Union clear decision and commitment to go in the direction of green transition, and we all have found in previous lectures and yesterday that hydropower is expected to be involved, to have its role. Maybe not exactly as it was to provide a base load 100 years ago, but its role will still be important. But then this green transition, this had really brought significant changes. And these are reflected also in courses at universities. Namely, what happened many years ago, decades ago, we had courses about hydropower in most of technical university, mechanical engineering, and so on. But then with this green transition and everything that it brought together, new disciplines were introduced, or knowledge on I don't know, wind, recently hydrogen, and things like that. And this all kind of dissolved this old style engineering knowledge, which was heavily on design of machine, how the blade should be shaped, and all these were essential parts of the courses. Because obviously number of lessons couldn't be increased, and by addition of new renewables and technologies and courses around them, this shift came such a way that now we teach more general overview approach that will be later discussed by Daniel. But let's please now first introduce ourselves. Let's start.
1 minute.
Whatever you like. I mean,
This is George from Greece, from National Technical University of Athens. My PhD was many years ago on combined use of wind energy with hydro pump storage for autonomous power systems. And I would say the last more than 20 years, I am involved in the education sector in NTUA. Especially, I follow the two masters, one European and one European in China, on renewable energy sources. So I think I am here to bring the experience that I have from these two masters, and also the teaching on hydropower in NTUA.
My name is Roberto Renato Stopar. I'm a senior research and test engineer with many years of work experience in Scotland Turbo Institute. Thanks to the strong link between the university where Marco works and our hydraulic laboratory, I had the opportunity to start as a student work practice there in the laboratory, and then continue working in development projects, model, turbo model testing, site testing.
Now you work with customers also, right?
Yes.
Because you speak so many languages, people cannot believe. Thank you. Thank you.
Yeah, I'm Daniel. I'm still student, like Marco said. And yeah, I'm still both student and also employed on the Wien, basically in a research group of AROT for a couple of years now. And so yeah, but still representing the students on this panel, I guess.
Yeah, thank you. So as you see now, we selected one professor, one professional from industry, and then the lab designer and one student. So let's hear what they will say. So we go first to companies. You have to stand there. I just heard for the time of presentation. So hydropower image in the everyday's life or what we hear in newspapers is rather poor. Because of environmental issues. Of course, this differs from country to country. And also within the field of engineering, if you ask other engineers, they see that as a mature technology. Not all are aware of the requirements of the green transition and changes it had brought. So they see very little development potential, some of them. This does not help students and companies for sure. And something you may have realized is that revenues in hydropower sector in recent years aren't very good. For companies in Europe, some of them struggle, as we might also see. And I think the salaries are less than in other disciplines. If you compare that to computer science, maybe for sure less. This is driving students away very much. Cost of living are expensive, especially in towns where these companies are located. I think I should switch the slides, right?
Yeah.
You can present your view.
In general, companies believe that okay. In general, companies believe that overall knowledge of physics, mathematics, material is well enough. It's covered in bachelor study courses, while in hydropower and hydraulic machinery, companies need more in-depth knowledge, which is covered in master courses, master study courses. So it's this includes CFD, then experimental work, testing, measurements, modern design, manufacture methods of hydraulic parts. And I would add this about the experience it's so more so very welcome some work practice during studies In general, we also think that curricula in EU countries, in universities at EU countries, are well appropriate, um, uh, appropriate in the immediate needs of companies in respective countries, so European Union. But whether these courses are appropriate for future needs in hydropower or green transition. So we have seen that manuals and textbooks could be written new or being updated in hydraulic machinery and hydropower engineering with new findings and customized to our new needs in operational behavior and requirements of how these hydraulic machines are operated, which change in last decades. There is constant pressure on there's constant pressure from buyers to manufacturers to have in control or to lower total costs of total prices of ownership. And
Roberto, when you say that that there's need to lower prices, how this reflects to students' opinion? Do you get some feedback from that from students? Is this that helping them to do something cheaper, or is it driving students away? What do you think?
it drives away.
Okay, thanks.
So for this, so this follows on general sentiment to to make a positive result and on investment as quick as possible of the product or service. And this then denies the manufacturer the need to for research. I mean, this denies the manufacturer goals for research in very short time. Very short time. Needed is basic. Therefore, needed is basic task of project management on projects to take price and time reductions which happen combining with good overview of modern manufacturing technologies, modern sliding and sealing materials, heat and energy exchange techniques.
I went to slide on skills now. That's okay.
Yes.
Okay.
So students lack practical skills and experience. This comes from school system, which heavily relies on theory. It starts already in high technical secondary schools, whose workshops and laboratory might be not so well equipped with tools, devices, machines. The way that these work practices are carried out. Knowledge and knowledge of mathematics and physics is important, but without experience with real world projects such as designing, manufacturing, providing engineering services to customers or so.
Roberto, when you talk about discussion with customers, when exactly students then start to or employees, new employees start to work with customers? Is this pretty fast after a year, two, or it takes longer?
Yes, actually, we after students, so when we employ,
Yeah.
I mean,
Yeah, after the employment or after your first contact, maybe when they work with you for some months,
Yes.
maybe before their
Already.
graduation or bachelor.
Already we acknowledge the work of the students if they participate in the project, commercial project. We introduce them, and then when they're employed, it takes time to bake in. So the student comes with, I say, like knowledge, skills. They're like stones, loosen stones, and then the experience, work experience, comes as a cement to
To connect these
To
things. Yeah,
connect.
this can be then done in companies.
And usually, instead of yes, after 2 years, we can say 3, 4 projects to turn around from the concept, planning, execution, and finishing the project.
May I?
Yes.
I want to ask you if you think that the employers need some skills from the students who are coming, or they need new employees that they will be dedicated and they share the same idea and to focus on this and stay there. And because when some companies they ask me to recommend some students, they don't ask, okay, they want to be energy engineers, mechanical engineers with energy focus, but okay, we don't need some necessary skills. We need somebody who will be dedicated, who has the same goal with us to develop renewables, hydro, wind, etc. So this
Thank you for the question. Yeah, this I already encountered with this. There are like two theories. Yes, one that like super skilled and only like producing, and the other no, we need just some like plastiline. We will mold it in our way. That depends from company, I think, to company. And, we welcome, since we are a hydraulic machinery company, we very welcome previous knowledge and skills. previously taught at universities. Usually we very good cooperate with neighboring universities. They're even executing laboratory exercises at our hydraulic laboratory or our it's not sightseeing, but
not sightseeing, but real exercises with some measurements, excursions, and so on. Yeah.
yes.
Yeah. Roberto, I have one question. When you first see a student, what is more important? I would like to expand a little bit your question. How much, in addition, you consider this social skills, personality of person? But I mean, I'm asking because it's not mass production; it's prototype production, hydropower. This means that the roles are not so fixed like in a company mass producing something that maybe these personal skills and qualities, let's call it like that, are more important. What do you think on that?
Yes, Turgut has, like he said, this work product is engineering services and some small hydro products. But yes, this mindset. So it's like we dedicate to like unique service or product, and we very welcome if the student has or it's open to develop soft skills such as languages. Then software ability to learn new software, sales negotiation, conflict resolution, and then that has ability to independently search for information needed for the process for the work process. It has critical thinking, so that not everything which is published is pure gold. I mean, information can serve for some purpose too, and it's strong in ethics and integrity. It's honest, impartial, and to clients, and objective to clients and to colleagues. He's willing to be part of team because we are team of engineers. So good team player. And
good team player and able to do things on his own when needed. Yeah.
Then, but relying like you can have conscience that okay, yes, there are many like occasions that you stay alone in the laboratory in some rare hour working, and like you think the rest went at home to home and the left here, but actually the work
team spirit.
I present in that current situation I perform, somebody has to prepare something or relies on me that I will work in the afternoon or night and will analyze next day with some proper conclusion. Some other team member.
So if I understand you well, these qualities are highly appreciated in a company producing hydropower equipment, right? Probably more than, for instance, car industry, which I mean has processes well established, and you cannot jump away out of that. It's very, very structured, the work that you may have in some other industry. Now, please be honest, Roberto. I would like to ask you about salaries, because that's important decision. For instance, Ljubljana, where we live, or vicinity, to rent a flat, to buy a flat, this is all expensive. So do you think salaries are good or not for hydraulic engineers starting their working company? You can just say yes or no, or no.
Actually,
Now we see why there is little demand for work
Yes.
like that. Yeah.
we are looking for young engineers or young students at the end of studies. And yeah, usually it's like we get some, we're not so sensitive on salaries.
More dedicated to work than to be paid well.
We as a workers, we are pressing the management to listen us to. On the other hand, I have luck to be also in the preparation of future projects or offers for engineering services or products. And two, there's a price pressure to be competent on the free market. So we have to be competitive with the price.
Yeah, thank you for being honest on that. I also, when discussing with students, realized that after Corona, with the huge spike in prices, some disciplines were able to increase salaries also. But as far as I see, hydropower is not among them, at least with students that I have spoken with. This is like, and that's not good. Before we go to next presentation, you will do that, right? I would like to ask you here about salaries and things like that. How how you think this problem of engineers being more attracted by hydropower could be solved?
May I give an advice? Those of you that you have an experience on hydropower, even in education, research, or professional level, you have the chance to move to the other sectors very easily. Why? Because the other sectors are simpler. And I have seen many people with experience on hydropower to jump to the other renewable energy sources or other energy sources. So if the salary is not enough in this sector, you can think about this.
Yeah.
You have the flexibility.
Yeah, we can vote on this, yes.
I haven't seen the opposite.
Students and engineers.
Yeah, they're not jumping. Well, maybe that salary is not just easy work, you know. Yeah. Yeah, I would like to discuss that comparison with other fields because in my university and many, as we'll see very soon, this hydropower is being part of turbomachinery courses. This is quite often, and so it is at my university. And comparing, for instance, manufacturing and everything for the design and manufacture of fans, which is turbine machinery in all basic equations, supply and everything. But you know, it's in my opinion easier from someone working in production of fans or heat pumps or whatever to jump to something totally different. For instance, to car industry, then going to hydropower, which also limits the flow of those wanting to work on hydropower, because internal procedures with making prototypes may be, as far as I know, very different. While mass production companies, they have these internal protocols much more aligned, and some working on turbine machinery also obey to same automotive industry protocols as ABQP or something similar.
So hydropower makes good engineers.
Yeah, that are used then in other fields of engineering. Some comments from your side. I will bring the mic to you.
in my country, well, I'm doing is from Turkey. In my country, there's a situation like that. When the students are educated in mechanical engineering or CFD and dynamics, they learn how to design a turbine, and also the defense industry is becoming very important in Turkey, and they offer high salaries to those students who know CFD analysis, and they prefer to work in defense industry. Yeah, that's the situation in Turkey.
Others? Then Daniel, mic is yours.
Okay. So okay, in the last 2 years we have done basically. I think it was last summer we started to think about this, and then we created like the first survey. First survey was then published in Brussels at the last face-to-face MC meeting, and yeah, was then published or presented at least at the last face-to-face MC meeting. But this contain also a more general view of the hydropowers, not only specific on education, but we asked people also to give their opinion and give us information regarding small hydro or general energy demand, and not only the education. So now we started a second one, and just starting from basically using the old survey and then conduct a new one, just specifically in education. And in this one, the deadline was in February, and till now we have kind of evaluated a little bit the answers which we got. And in total, as you can see, like close to 70 participants all over Europe. But at the end, we saw that there's still some, for us at least, still some information were lacking. I mean, especially the distribution across countries was kind of not so optimal, because some countries are more active, or from some countries we got more answers, and from some other countries less. And so we started to search by ourselves, and it was kind of really challenging and really a long process, because data availability, especially while searching for dedicated courses, including ETCS, is not so easy, and especially easy accessible. And this is still an issue also. Our university, for example, the website is just horrible. But we saw this on other universities as well. So really capturing everything is not easy. So here you can here you can see the distribution of the. I think the master is wrong, but here you can see the distribution of all countries. From both surveys, like 2024 and 25, how many answers we got. And okay, this is the slide master should be on white, because everything is written in black, so I can just talk you through if. And because we searched for some keywords, as you can see in the bubble here, and especially we searched, for example, for the key hydropower words. It's like hydraulic machinery and so on, and then yeah, lecture titles we structured the way in for example, hydraulic machinery, or also an electrical side and on the civil side. So we really put down some keywords, and in the bubble you can see the keywords of the lectures we found in all of those 300. Then some words about about the results. Weighted in our cases, when we, for example, have a lecture with called hydraulic machinery and contains 4 ETCS, and because it's called hydraulic machinery, we evaluated this as factor 1 because it's really the targeted lecture we searched for. So at the end, we summed up the ETCS, and the higher the ETCS in a country or in a city, the more lectures or the more equivalent ETCS lectures are offered. So it's, for example, another example, when a course is called renewable energies, it's kind of, we evaluated this as like 50%. That means four ETCS lecture is like equivalent for 2-1. So it's because the hydropower is not dedicated or not really represented in the name of the lecture. And as you can see, most lectures we found or were found in the survey were like 2/3 were master courses, about a quarter bachelor, and the rest are PhDs, especially PhD courses. So again, here the distribution all over Europe with the sum of the weighted ETCS, like mentioned here. Yeah, colors are not so good, or the background is actually quite bad. But you can see that, for example, in Norway, there's a high share of really dedicated hydropower or dedicated courses with the targeted words. Also, for example, France is not too bad, or even Poland we found. And here we have another distribution. For example, this is the same, just distributed all over the cities of Europe. I know there's still some cities, still some cities missing, because it's like I said earlier, the data availability is not so easy. Then yeah, I think the next 2 slides are kind of a little bit showing the reality of hydropower education. This is on the left side. I've put the hydropower production the energy production in percent of the total energy production, and on the right side the absolute amount of lectures we found or we have collected in the survey. And as you can see, for example, in Germany, there's a high. There are a couple of higher amount of numbers of lectures, and compared to the hydropower production is actually quite low. And another way around is Norway, where the hydro share is quite high, and then also lectures are there, more lectures offered.
But this is very easy to explain. I'm sorry. Like I'm looking at my country.
Yeah.
And we buy equipment from Germany, so
Yeah.
easy.
Yeah.
The big man. Where do the big manufacturers sit?
Yeah, sure. Yeah, sure. But I guess this is not only linked to that, because I want to, especially later on, I think there's a big lack in education, not in education, but in research funding. And the more projects normally are at universities, the more people are able to be educated and working on a specific topic. For example, if you have more hydropower projects at your university, the team is probably bigger. That means more thesis, more people involved, and that also means normally more students within the courses. And I think this is also big. It's really important to mention. And another map, now I put the installed capacity, and then things are changing a little bit because of countries having a high share of the installed capacity, and using hydro especially for grid regulation or ancillary services. But the general overview is still the same. So, and lastly, I put again up some comments from people we got, and yeah, I think especially this one, I like especially this one here, because if research is or if there's too less research within universities or within a different sector, within a certain sector, there will be it's really hard or really not, yeah, it's hard simply to attract people because they see no possibility within that sector, or they see not such a bright future for them because they don't see projects, they don't see funding, they don't at the end they don't see thesis, and then they don't see work as well. So yeah, that's basically it from the survey. If you have some questions.
Well, I have some questions, but more important, whether someone of you can add comments on that what Theo Wien did.
If I know you bring it up with us, the would you suffer? Thank you. Thank you. But just a question, just if you can a little bit sample is when you were hearing the word renewable energy, let's say in the course you were saying like 50%, let's say the weight. What we have seen, and I think George can also account to that, is that we have, for example, different schools that are oriented to different types of renewable energy. So if it's like a civil engineering or environmental engineering, I would expect that hydropower will be the dominant, let's say, technology. But for example, in chemical engineering, maybe it would be 5%. Or in electrical engineering, it would be like a 4%. So would we make a distinction between the subcategories of engineering, let's say, just an idea, what do you think about?
Yeah, our approach in that regard was that we, because normally we searched for really the dedicated lectures in the curricula on the websites, and we got really into the lecture and searched for keywords. That means we looked like, is there PV, is there more PV, or what does the lecture contain? And if we structured it a little bit in this way, and did some courses, yeah, sure, there was PV like 80%, and we said, okay, it's just 25%, for example, of weight winning. But when there is more hydro, like 50%, for example, of the whole lecture, we said, yeah, okay, it's 50% is adequate. So we tried to be as neutral as possible, but and not biasing the results in that way.
Just to give you like a positive view about it. So we have also other technologies like for us, we have courses that's called energy technologies. That's not the renewable side. But because of the work that of my doing or other people in the field are doing, all this like turbines for hydropower, stuff like this, we have incorporated into the lectures. So we have renewable energy lectures that are more say soft and sometimes as elective courses. But in our core, let's say, curricula, we also have technologies that are related to hydropower. And not only the turbines, it's a lot of things that, everybody sees this from his own perspective. But, so we are focusing on the energy conversion. But there's a lot of people who are dealing, for example, with the water flow, which is a totally different story, but again, part of the equation. And these are courses that maybe are not reflected easily to somebody who cannot really check everything, But I think it's a positive thing that a lot of people are incorporating gradually a lot of things in their own courses related to similar things.
Yeah.
Well, I'm doing this for the course Sustainable Electric Energy Sources. I have approximately 50% of hydropower in that, and I'm always criticized by the students. So what should I do now? No, but please comment on that. These are important things. I mean, the most important part of this session is, I guess, here. And don't forget, if you don't ask questions now, you'll come home earlier, and you will not have the opportunity to work anymore today.
Just want to put one thing on that, because for example, if you're not reading into the hydropower field, or you want to at a certain point, I think you have within studying, I don't know, something, mechanical engineering, civil engineering, you have at some point you have to decide where you go and what students are doing. It's going by talking to each other and then saying, yeah, this lecture is nice or this lecture is nice. And the other option is and they're searching through the curricula and what you can clearly see and what also the survey shows that really the keywords of Hydro are not anymore in the titles, and I think this is a big issue. But and this is also at the end why we kind of try to wait results, because we simply saw that dedicated the hydro keywords which we searched were really in really minor just. And so we started also to go more deeper within the lectures and then try to search some percentage and some really dedicated or really listed topics, how much how much hydro, for example, is covered and how much everything else is covered. And normally I would do that, and I've done that the same. If you're searching for courses, you're definitely going through the description and the topics which are handled in a lecture. And I guess other students in general are doing that. But if the keywords right at the beginning are missing, it's way harder, I think, to convince or to be present for students representing a certain field.
Sure. Barbara?
Thank you. Okay, yeah, that's good. Yeah, I can confirm Daniel's statement. Language is forming reality. So if you don't find the appropriate language, you won't find what might be existing but is not visible at all. What my former company did was Voith Hydro in Heidenheim in Germany, as a big manufacturer of equipment, was to found their own faculty to educate hydraulic engineers in Stuttgart University like 15, 20 years ago, together with ENBW, which is a big utility in the region of the southwest of Germany. And they still have a lot of hydro and need engineers and their engineered knowledge. So what they did together is to found this faculty again and put an own person, an own engineer as a professor into this faculty, and they both paid half of that for 10 years. So the university, the company, and the main operator in the region, or in whole Baden-Württemberg, which is sort of a state of Germany, paid for that model for 10 years. They funded it to simply have engineers available that they needed with the respective knowledge. But still, reality in companies for doing hydraulic layouts and electrical layouts and balance of plant things is that you simply need to educate the engineer coming down from the university again for roughly 3 years until you have developed the expertise and the expert, male or female, that you would need to send them out to customers, because we were talking about client context formerly. So that's what I know. I'm 10 years out of that. I don't have the impression this has changed so much, but at least it was sort of a life-saving thing that the R&D head of Voith Hydro at the time, Dr. Siegmund Etter, I think some of them know him, was the one who drove ENBD or W towards that direction together with the University of Stuttgart. That's one model you could do. What I think is important that you become visible much more already in universities. So the language is one thing, the wording, the buzzwords, but also the attraction for younger people. And I mean, at my age, I also think, how the hell do I address them? Which channels do they use for their communication? We see that in that hydroclip competition. How do we reach the ones that should apply for running for that prize? And they use very different media. It's not this simple LinkedIn thing or even Facebook or Twitter. They are in very different channels in the meantime. So I think one has to get younger communication also to become audible and visible again. But that's my experience. It's not based on statistics, but at least for Voigt, for the company, for the industry, it worked for quite a while. I don't know how the situation is now after more than 15 years of the model, but I understand that my former colleague who went there to be a professor is still there, so it must have worked somehow. Thanks.
Thank you. So,
So now that you called me, then I have to say something.
you're from company also.
Yeah,
I mean, share them.
yeah, I actually Barbara said what I wanted to say, so that's why I said like I have nothing to say more. But in our country, first the generation of professors on the college were expert people from the industry, but there were no professors, so they had to step up and they had to teach. First generation was people who would work in the power plant. And then second generation of teachers, of professors on the college were their students, their best students. And then now the third generation is basically leading the show. And these people have never stepped into the factory and are slightly disconnected from the industry, so to speak. So I think that what Barbara said is the correct way. Basically somehow reconnecting industry with the professors to form some kind of alliances where professors come into the companies and work for some time there to see how it really looks and not how it technically and theoretically looks. And then on the other side to send some experts from the industry to teach. So and then to get this gap bridged and to make courses more interesting to students. Thank you.
Thank you.
Thank you. I'm Sebastian Jan from Romania, in Timișoara. I am from the Research Institute, but I also am PhD supervisor in Polytechnic University, more than 5 years. And I graduated of hydraulic machinery, mechanical engineering. I'm young, 30 years ago. And in our field, changed a lot. And we have to think in what's happened in the market in order to understand and to see if we are able to adapt to the movement on the market. What I would like to emphasize here, it's the knowledge and skills we are talking here. Indeed, for hydropower means high level of knowledge. Today, generally in the eastern part, the state do not want to invest. Specifically in some parts, they would like to share the education with the companies in order to try to have a bachelor, let's say more general knowledge, to go to the master, to the some specialization, and after that to the PhD. For that reason, to the high level of the university decision, generally they would like to have closer the connection with industry in some parts where the industry was not able to resist on the market. Other industries came, for example, in Timișoara, we have a lot of automotive industry, was a lot of companies who joined in the western part of Romania. After they moving in the eastern part, they trying to move to Ukraine, but was not chance due to the war. And for that reason remain in Romania. That was our lucky. The longest region was China. But unfortunately for them was somehow impossible due to reasons in the market and impossible to save the investment. And that was the impact also in the educational side. The students are very smart. They are building the market and the chance in order to develop their career. And for that reason, they're moving very fast in the chance in order to be employee as fast as possible when I graduate. And that is very, very important to have this in our mind. Talking about the training school, because also I am the person in charge to the training school in our post section. Together with our colleagues, we have the chance to organize up to now 3 training school in sustainable hydropower. And we try to support all of you, all countries, in order to be part of this training school. The sustainable hydropower standard was developed in 2021 and was updated in 2023. And generally in the universities, the knowledge and the skills are developed are more focused on the very clear domain, meaning engineering, mechanical, electrical, and it's more difficult in order to mix and to give a broad knowledge. For that reason, we observe in the training school, the youngers who join us, generally they said is the first time when they learn. And I would like to mention one very deep discussion with one of the participants who mentioned after the training school, they said it was good for him to participate to the training school because he realized that the hydropower is not only mechanical engineering. That is the reality. And that is important to understand the hydropower, it's a teamwork. Generally in the universities, it's more difficult to invest in this kind of development of the knowledge and the skills on the wide domain. And maybe we have to find this kind of environments in order to develop this kind of transdisciplinary knowledge to stay together, and especially for the youngers, in order to give them chance, in order to form a new generation of the specialists and also to know each other in the hydropower field. Thank you for your attention.
May I just quickly comment on what's previously said? Well, I would going slightly against what Miroslav and Balvas was saying. I don't think that industry's role should be to finance universities. I think universities should try to finance by themselves. So that means for research projects primarily. Sure, but when a company comes to university for separate projects, this is nice. But I think when universities are not biased, are influenced or too much by the companies, I don't know if this is really a healthy system. I think universities should definitely live from research projects, and when there are too less research projects, just simply at the end this means less thesis, and for example, less thesis, normally less people in the courses, and if there are too less people in the courses, the university or the directorate of the university can also decide, yeah, there was just, I don't know, a couple of theses on this topic and lectures on this topic, well, just a couple of exams in these topics, they just say, yeah, we will stop this lecture. And what happens when we will stop this lecture? Yeah, the topic gets erased basically from the curriculum, and even less people are then coming to a certain field. And I think in this case, or this thing is really important to mention, because if there's too less funding, this is like it's like a rat tail. It really starts at the bottom, I think, and it goes. It starts at the top and goes really down to the bottom. And I think we should, or in general, it should be addressed that there's way more research in certain topics. For example, if you're looking on renewable energies, on the European level, there is just this year is just one horizon call, for example, but there are multiple calls for wind and PV. So this is also, that means also that hydro is the two options. One is hydro is seen as really mature technology, and the other one is underrepresented, for example, in the lobbying part, or people don't see it necessary that hydro is so important for the grid stability and so on, or in general for the electricity market. So
Yeah. Thank you, Coach. Now it's your turn, please.
Thanks. Going away. Okay. It is my pleasure to be here. Thank you for the invitation. So last but not least, we will see now the large picture, I would say, because we will see what is the role of hydropower education in the renewable education sector. And I will bring you my experience from the two masters that I told you, the European and the Chinese. Both of them are on renewable energy sources. In the next slides, I will show you some. I will not show you some details about these masters. The concept, the scope today is not to discuss about the masters, but to see what happens with hydro in these masters, especially the first one, which is the European Master on Renewable Energy Sources since 2002, so almost 25 years ago. A collaboration of universities and students change country and university to take the knowledge initially in a core university and then in a specialization university. And what we want to highlight today is a paradox. What is the paradox? The paradox is that hydropower plays only a minor role in academic training on renewable energy education. Besides the questionnaire and what you have collected from the whole Greece, I take the examples of two masters on renewable energy sources. But as we will see at the end, as a global employment data show, hydropower remains one of the most significant renewable energy sectors worldwide. So this is about EUREC. So hydropower is only included in the core semester, in the general fundamentals of renewables. And as regards the specialization, we don't have, 25 years ago, we don't have a specialization on hydropower. We have other specializations. Here you have a list of the core semesters in France, in Spain, in Oldenburg, and in Hanse. Here you see the specializations. We have PV, we have wind energy, grid integration, solar thermal, ocean energy, sustainable fuel, but no hydro. So and the same is the situation in ICARE, in the ICARE. What is the ICARE first? ICARE is an institute created in China, in the famous Wuhan city, since 2010, and it is a collaboration between Europe and China. And one of the main activities is that we offer the European universities, we offer a master on renewable energy sources in China, in Wuhan, in HAST, the the hosted universities, the Hwaseong University of Science and Technology in Wuhan. Wuhan is in Hubei, the province which hosts the Three Gorges, the largest hydropower plants. And even in this province, in this city, we don't have, let's say, we do not focus on hydro. And here is again the partners, the Chinese and the Europeans. Most of them are coming, the Europeans are coming from the EUREC network, and so we call this two masters as brothers. And the idea is this double master diploma. And here is an overview of the courses that we have. There is no hydro. Hydro is a part of the energy conversion. Is a small, during 1 week, 16 hours, this is what we cover on hydro energy. So now if we move to the last slide to see the paradox, this is coming from the REN 21. The REN 21 is the Renewable Energy Policy Network for the 21st century and records the development of renewable energy sources in the world. And here we see that hydropower is very important. You see that it supports tens of thousands of jobs, especially in manufacturing, operation, and maintenance. Of course, here we see the continents and the geographical dispersion of the jobs. The 2/3 of these jobs are in Asia. So I don't know if in Europe we create new jobs in hydropower or we lose, as we discussed in the beginning. Of course, hydro remains very important in specific countries, and this is also Greece. And if we focus now in NTUA, I brought here a list. I don't know if you have found this during your questionnaire, a list from the mechanical engineering school. So this is the list of courses related with hydropower. And this is in the civil engineering school, largest list, which covers everything from hydraulic machines to dams, fluid management, and water resources. This knowledge is valuable. It is in a postgraduate level, so we don't have in a master degree, we do not offer these courses in master degree, so we see here another paradox. In the lower level, to offer, Yannis knows this very well, high level knowledge in comparison with the masters. And to close this presentation, I want to underline that the energy transition is not just about innovation. You said about mature technology. I would say that hydropower is the traditional. Mature is also wind and PV today. Maybe it's not hydrogen. But what happens today is that we need hydro, and especially reverse hydro, much more than in the past, because the other renewable energy sources has already reached a high level of integration. So if we discuss about energy transition, it's not just about innovation, it's also about integration. And at this part, we need hydropower. So hydropower maybe is not the most visible or fast-growing technology today, but it remains a fundamental part of the global renewable energy landscape. I am sure that you have some questions about the Chinese students.
Yeah, sure. That's what I I ask you. So I'm interested how if you see the difference between European and Chinese and how one decide and how the other group decides.
The Chinese are very dedicated, I would say, and they respect very much the professors and the universities. And they trust more what it is offered. In Greece or in Europe, if you ask something to a student, he says, "Oh, why this? When I'm going to use it, it's useless for me. I don't care about this. I don't have the calculator to make the exercise." The Chinese, they trust you more. Do this, they do it.
Yeah, that's how they are from.
But the selection, how is the selection in China related to the Europe? Meaning how
The universities that are involved. This is the answer. Now, hydro was included the last 6 years. It was not from the beginning. We added in this energy conversion. There was a gap, for sure. I have mentioned this from the beginning, and when we found the right moment, we added. Of course, in a very, let's say, is the problem that I have described previously, that in the civil engineering school or in the mechanical engineering school, you have the possibility to offer high level courses on hydro machines, etc. There, where you have an audience which is a combination of background diploma, you have mechanical, electrical, even industrial engineers or control engineers. They have other categories in China. It's difficult to focus, for example, in hydraulic hammer. How to explain this now to electrical engineers, for example?
Tonight at dinner, not now.
I would just have a question in general for Athens and for China, because you mentioned or you listed all those lectures and said that hydropower is at some point it's mandatory, but a lot of times it's not. Do you think this also plays a key role if a lecture is mandatory and if not?
You mean in NTUA, in our school, if the courses are mandatory or?
Yeah, for example, or in general, your opinion on that. Do you think
If the students they prefer to attend this course, if they choose.
Yeah, exactly. Do you think that?
Do not so much as in the past.
Why?
Yeah.
What is the motivation? What is the reason?
I think the policy. No,
Of who?
the policy, what they read in the newspapers, in the energy news, in the energy forums. So the discussion about hydro maybe is less than the discussion about the others. Especially the last, it's not the same today, because today, after the blackout in Spain, we need storage. So I expect that this trend will change.
We need more blackout.
We need more blackout. Did I answer?
Yeah, but I don't you think when, for example, that it's difficult in general for certain topics when courses are not mandatory, that attract people to those courses is way more difficult. For example, when people having, for example, a first hand on some courses which are mandatory, they can get like a feel out of it. I don't know, a kind of fluid mechanics when you're teaching fluid mechanics and involving some, for example, some hydropower stuff. Don't you think this could bind people more, for example, than just tell them general stuff and then they have to attend a separate course and say, yeah, you can, but you don't have to.
Yeah,
Actually, we have two courses. The first one in the NUA, in the mechanical engineer school, the MBA, you have two courses, hydropower. The first is hydraulic machinery. This is a mandatory course at the third year. So we have more than 150 students there, maybe 200 students, and a teamwork, work, which is not obligatory, but they participate more than 100 students. So there is a large interest in the machinery and
But it's still mandatory, isn't it?
yes, but they participate in this teamwork that is not mandatory for them. So there is an interest, but then the ninth semester, fourth year, there is the course
Hydro energy,
which
so all
is
small hydropower.
with George, hydropower, small hydropower plants, and also we have introduced the tidal energy and the wave energy. There we have more or less 10, 12, 15 students at most. But they are very dedicated. They like very much what they are studying. But this is the number. From about 200 students, only 15 select the hydropower. I think that the students today are more interested in technology and advanced technology, even if it concerns hydraulic turbines, and not the general energy flow or management.
Old-fashioned flow.
Yeah.
Yeah. Thank you.
Edward?
Just a general comment. It seems to me, from my experience both in the UK and in Greece, that engineering is not so attractive anymore. I have to accept that it's very difficult. It pays off. It doesn't pay off. And in general, from conversations, especially in the United Kingdom, is that the industry does not pay enough engineers. If they need to have good engineers, they should be prepared to pay. Somehow it's a market issue, I think. Now, in terms of universities, I think we are very slow in adopting or in understanding that the young generation now is different than our generation. First of all, they learn it in a different way. It's a generation who were born with the smartphones. They don't have the patience to sit down and study the subject. It's a completely different world. So not only for engineering, I think we are very slow as universities to understand the requirements of the new era somehow, both in terms of content, of delivery, and objectives. What is, for example, now it seems that Google or Microsoft, they are in a position to educate, for example, programmers. Probably you don't need university to have a very good Python programmer anymore. They can more or less qualify somebody that he's an excellent guy to do this job. Now we have artificial intelligence. Since two years ago, nobody trusts you now. They check in ChatGPT and say, okay, an axial compression is better than centrifugal. In fact, so even they don't go to Google to search now. They go to ChatGPT, ask questions, and then this is like a dogma. It's like a Bible. So it's a different way of thinking. And as universities, I don't think we have done a lot of work to understand what's happening. Now, in terms of hydropower, it has a very small role in curriculum. And as new technological fields come into engineering, inevitably we have to incorporate them in a rather softer way of teaching. And then you expect from serious industry to take somebody and educate him to the level they want him to, I mean, for their own production or whatever. So it's a very complicated issue, and it's not a problem only of hydropower, actually. Engineering starts being an old-fashioned sort of image to many young people. This is my contribution to the discussion. Something else?
Edward, you want to say something? Probably, and I say no, so that people think that then we can say. Yeah, I mean,
noticed since 30 years what's going on in the education. And I mean, I know the situation what was in Stuttgart, what happened. I know the situation what happened in Vienna and so on. The question of is it mandatory or not? I mean, if you're happy that you're losing 90% of the students, which are mandatory, that then 10% come to the lesson to hydropower. You should think probably this is a good way. Yeah, just to think a little bit. We need probably in the future more people. In Vienna, is it like Daniel said, we have no mandatory courses. So we have in the bachelor a modular system, and I think student can pick or has to pick four modules out of 17 or like this. Yeah. So means that if we put the same pressure like on the mandatory course, nobody will come. Definitely. Yeah. We have also only those, let's say 30% or 30 students maybe in class, but we are still quite lucky. And the one argument is, of course, salary. Yeah, everybody wants to have more, but what I see with the youngsters when I'm working with them, it's not salary, it's recognition. You trust them, you give them opportunities, and you show them that they have also a future opportunity. So it doesn't just go on the university. I was organizing a very long time conference and was very often with the industry on the table in the evening, looking to give the youngsters perspectives, give them master theses, pay 2,000 euros for master thesis, and you will get somebody. If the industry doesn't offer any or show provision, if there's always, we don't need engineers, because I don't know, ChatGPT solves everything. How should a younger have a vision? If we are not creating a vision, then why should they join us? We are old, but most of the teachers, sorry, including me, experience. Sebastian is young. But giving them vision, giving them perspective. That he has his entire career in front of him. So he needs a job in the future, and the job they have to be smart. And I think if you say, well, the Chinese they follow what I'm talking, what I'm requesting. I mean, is this really what you would like to have? Is this what the industry would like to have? Somebody who says, you push him like here and then he stops. I have the students. You push him here and he stops. You like to push him and he runs around the entire building. I had also some PhDs from Nepal. It took me 2 years to explain him not to believe what his level above says. To say not to rely on what is the number. The discussion was on one number, 44,000 megawatts potential in Nepal. And that brought him to the point to think where this number comes from. And the number came from a PhD thesis in the 60s in Russia, where somebody just had a map and said, Nepal has 44,000 megawatts. And he did a modeling, a digital modeling of entire Nepal, GIS data, precipitation, and all. But he didn't believe his own numbers. And that's, I think, we should really think about. Give them vision, give them opportunities, give them challenges, and give them, of course, money. And that's what we are trying here. Sorry.
Okay, this is the final time that I talk. Yeah, so on the mic. So first of all, I think that ChatGPT might be actually a good thing for us. Because last year I was going on several college days where we were trying to attract students, and we got much more attention than before because students are very much aware that ChatGPT can program very well, that the average programmer will probably not be required soon. They're also very much aware that during few last years, several large companies like Google, Facebook had large layoffs. And so they are not that much interested in programming because they're realizing that their job could be very soon in danger in that field. So that's number one thing to say. Second thing that I want to say, because Daniel said something and I think that it came across bad with what I said. I never said that industry should pay to go to the professors or something like that. I never said that. What I wanted to say is something like this. Imagine when a preacher, a priest, starts telling you how marriage works. Okay? And he has not one day of true experience. And then he talks about ideologies and his great ideas. And then you sit there as a young couple that is ready to be married and you just, nod your head. And it's great. But it's something completely different when you enter the marriage and you see what it really is. So it's something like that when you have a teacher who never worked in the industry and talks theory that he learned from his teacher who also never worked in the industry, who heard that from his professor who maybe worked somewhere. So children today, students today are very skeptical. They can read bullshit. And I'm not saying that teachers are saying stupid things. They are relying on things that are written in the books. But as we have seen, books are from 60 years old, from some handbooks, some graphs, and so on. And it is important for them to see that they have hands-on experience translated to that. So it would be, I think, useful if teachers would maybe sometimes have some kind of work experience because of that. Thank you.
And having or getting some influence from a couple of people is also not too bad. Like at some stage having a mentor and so on, this is definitely helping as well.
Thank you.
Just a tiny comment, like titles or names of the courses would be more interesting for young people. Like you can make really frank and exactly straight to the point, but then you can use also interesting words or catchy phrases to make it more appealing. And the material also, what you offer there, to be more like people already mentioned that you need to be up to date and provide training, so they maybe will be more interested in advancing it. For example, add digitalization, artificial intelligence, all these fancy trend words. Of course, I understand for you as the professional, it seems like cheesy or not really showing the full aspect of the courses you provide. But if that would attract young people, why not you try that?
Obviously, we agree.
Yeah, thank you. Yeah, thank you. Yes. So we have come to an end with this discussion. I thank you all three for the presentation and discussion, and all of you for your contribution with discussion. And I didn't expect too much from this because it's kind of topic that that doesn't have its beginning at its end. It's we are many of us we are teachers here or assistants or whatever, and then it's I mean this is all the time some kind of work that you do daily, and you adapt and you see and you learn on yourself and you try to improve next year, and then you see whether it's good and so on. So I see this discussion as one of the steps on our path through our life as professors. It's kind of that we are always talking on meetings about research, but what we are doing at home is a lot of teaching, and that's how I see this meeting, this session, as an important that will bring us a bit further on the teaching, not on the research. And I would be happy if all of us, including companies, will remember this session here and then, and find some new ideas and some more energy to continue work, to do better, and so on. That's the final word from my side. Do you agree with that? You want to add something? No, yeah, he wants to add, but that's for next Planet Hydro meeting, whatever it will be. So thank you very much.